Well, good evening, everybody. I'm very happy to welcome you tonight at ROLI. My name is Nikolai Georgiev and I'm the Vice Chair of the UK Committee. And it's my pleasure to introduce Ben, who is our past Chair. It just doesn't make sense that he would introduce himself, so that's why I'm here. The microphone is used only for the recording. Can you hear me well? The level's fine? I think that we don't need amplification. Yeah, that's fine? Okay. Just a few technical bits before we start. There's a fire exit right there behind you, and there's another one apparently behind the screen. I would probably choose that one, but for those that are close to the screen, there's a way to escape from there. There's also the AES register, which is over there. I will pass this one, and I would ask you to just put your name and whether you're a member or a visitor. That's all really that we're asking for in the company that you work for. It's mostly for fire safety. The other thing is, I would quickly like to announce two lectures which are not yet on our website, but they are confirmed. So the first one is the December lecture by Frank Melchior. This is going to be at the BBC. It's going to be on object audio and the future of broadcast. It seems to be a very, very interesting subject. We will have an abstract very soon on the website. Our January lecture will be by Zoran Cvetkovic, who is a professor at the King's College London, and the lecture will be held there. Again, more details are to follow very soon on the website. And last, before I introduce Ben, there's something a little bit odd here. I've brought this drink, which I brought also last month. It proved to be popular, so we decided, well, let's have it again. And there is a reason why it's called the AS 67% vol drink, because it's pretty much that's the percentage of the alcohol. So be careful with it. It's very cold, but it is to celebrate our chair's baby. So Tom's not here today, but you know, he recently became a father. So cheers for Tom. And my pleasure is to introduce you to Ben Supper. And one last thing, may I say that, for me being an AS member, it's one of the greatest things about it is that I'm always surrounded by people who know more than I do. And it's been a pleasure for me to be on the same committee together with Ben. He's probably one of the most knowledgeable people that I know. Ben Supper. Thank you.
Thank you, Nick. Thank you, everybody, for coming, and welcome to ROLI in the glittering heart of London's East End. I'm going to talk today about reimagining the piano. That's the title of my lecture. My name is Ben Supper. This is just here in case I forget who I am. A little bit of background. I'm going to explain something about ROLI and the Seaboard throughout the course of this. I joined ROLI a little over 18 months ago now as a head of digital technology at the time. I'm now head of research. Things keep moving around in a growing company, and so roles change all the time. So I came here somewhat after the original conception of the Seaboard, when it was a working prototype and we were trying to make it a working manufacturable product. So I've been quite heavily involved in the development cycle. And some of that pain and joy and suffering and triumph I'm going to bring to you today. Nowadays I'm concentrating on the kind of things we're going to be making and researching next. Only a little bit of which I can allude to, of course, but today's talk is going to cover, well, three things essentially. Firstly, what is a Seaboard? What is it in terms of a musical instrument? What is it in terms of a cultural artifact? These things are kind of interrelated. What's been difficult about making it? Actually quite a lot. And why is this interesting? I'm hoping a third thing will be kind of implicit in the other two. I left a company that was doing financially quite well to join a startup that was kind of struggling for capital at the time, so it may contain traces of self-justification. But it's been a very, very interesting journey, and I'm very pleased I made the change that I did. So what is the Seaboard? Do we have Heen here? Yes, we have Heen here. I'll need you in a few minutes, but if you want to get comfortable now, that's great. Actually, no, let's do this now. Heen is a product demonstrator. He's been here a little longer than I have. It's his pleasure to have played the Seaboard through pretty much all of its incarnations, and he's now far better at it than I could hope to be in the time I'm given to practice. So I shall hand you over to him.
Cool. That's my name. And basically I'm just going to go through a range of sounds to kind of demonstrate the spectrum of usage you can use the Seaboard for. So yeah, let's get to it. So the key layout of the Seaboard is exactly the same as the piano, so which gives you yeah, so you can approach it like a piano. It's got like the same velocity. So yeah, you can play it like a piano. But then once you get used to the tactile feel of the silicon surface, then you can start making use of kind of bends and vibrato, which you can do simply by wiggling your finger. So yeah, you can do vibratos, you can do pitch bends just by playing kind of legato and over semitones. So that creates a bend, and you can bend further than a semitone. So yeah, and one of the great benefits of having the pitch bends capability at your fingertips is to simulate real-life instruments, especially string instruments. So, for example, if you imagine a double bass, you can add these kind of fine vibratos, and you can use the fretless neck for glissandos. So on the Seaboard we have maybe more volume for this. So we have a pitch ribbon at the bottom. Yeah, you can just, like now you can just add just a little bit of vibrato. You can't really get this fineness on the pitch wheel. And here it's so much more natural and musical to just. So yeah, it's all happening here. And apart from all the pitch bends, it's also pressure sensitive. So you can, if you, like, it's especially good for simulating wind or reed instruments because they have breath control. So similarly, you can, for this kind of flute patch. So yeah, as you can hear, you get the real organic tremolos. And apart from all the acoustic instruments or sample simulation, it's also great as a new interface for designing sounds. So, like, one way we think about it is, because now you can sync into, like, continuously sync into the keys, you can approach it say, if you tap it lightly, you get this bell sound. But if you sync into the note, then you can control the volume and the rate of the bell, and it's all up to you how you want to. So yeah, you get some really interesting textures just by kind of varying the pressure. And just to mention, all the expressions, both aftertouch and pitch bend, they come in polyphonic mode, so you can hold the chord and bend without affecting all the other notes. So, just another sound to show how versatile each patch can be, because you now can interact with it in different ways. So, for example, this one. It's like a clean brass sound. So yeah, you get this kind of. So yeah, it's all just one sound, and you get the cleanness, and you can, because pitch bend is mapped to the ring mod, so you can bend the notes to control that, and it's also pressure sensitive, so you can. So yeah, another great thing to use the Seaboard for is cinematic, or for film compositions, because again, using the same method, like you have the light taps, so you get this plucked harp sound, but if you sync into the notes, you can access different layers, and maybe a bit more. as a quick overview of the range of sounds, and of course with a bunch of other sounds that I can play here all night. But maybe we can try some of them later. So yeah.
Yes. Thank you very much, Ian. A couple of things I need to say which I should have said before. Firstly, John Watkinson has very kindly allowed us to use his loudspeakers for the night, and I hope you will agree that they've made a big difference to the way the sound could otherwise be in a room like this. It also meant that he could hear what he was playing, which is lovely. The second thing I meant to say was, what is the second thing I meant to say? I'm sure I'll think of it later. Oh yes, there'll be plenty of opportunities to play this. We'll leave it set up afterwards, so if anybody wants to come and do a little solo with nobody else listening too critically, please feel free. It doesn't bite. It's a wonderful thing. So one of the things that Ian has demonstrated is that semiotically Seaboard is a piano. It's got piano keys. It means that if you already play the instrument, you can transition to a Seaboard fairly easily. I say fairly easy. It probably takes between an hour and about 3 hours to kind of get used to the new feel of it, depending on who you are and how you approach playing. There are a couple of differences you can see. Obviously, Seaboard bottom, piano at the top. One of the more important differences from a point of view of a player is that while the piano, you can toe out the black notes, and as you can see, the black notes don't fall exactly between the cracks of the keys. They're sort of widened slightly to enable people with larger fingers to play. We can't really do that on the Seaboard because the whole point is there's a linear relationship between space and pitch. So we've had to cheat a little bit, and the black notes are now exactly between the whites, which can feel a little strange, but you get used to it very quickly by feeling where the ridges are. The other thing is a sort of semiotic artistic statement. The fact that the keys are reversed out, they're white on black. First issues of the Seaboard actually were presented like a piano keyboard with black on white. And we found that by experimenting with different colours and different textures, and by not having a piano keyboard there, people were actually more able, they felt freer and they were more willing to use the instrument differently. And that was really the intention, that this isn't so much an evolution of the piano as an alternative to it. You wouldn't want to play a toccata on a Seaboard unless it had been specifically written for the instrument. There are certain things that a Seaboard does less well than a piano, and certain things, as Ian demonstrated, that it does far better, and far better than a MIDI controller keyboard can. So, moving on, what is a Seaboard? This is a kind of cultural artifact thing. What we've tried to achieve in the first edition of a Seaboard is very different from what most disruptive style companies are trying to do. So while most first products are intentionally a little bit shaky and rubbish, what we try to do is come up with something with a real sense of craftsmanship and an awful lot of effort and styling, and a lot of expensive materials and labour was put into each Seaboard the first time we made it. If you look at what other startup companies are doing, first prototypes are always designed to be quite shaky. They're designed to fall apart, almost be semi-disposable. Get your name out in the market, make sure that people upgrade. With a Seaboard, technically to some extent it's going to be an Opus 1 product because it's our first attempt, but actually it's also a work of supreme craftsmanship. And that involves some very different thinking from the way I've thought before in my former career in the world of musical instrument manufacturing for a mass market company. And actually it's, as I will demonstrate, it's worked quite well. When I say same level of craftsmanship, obviously a piano's got thousands of moving parts and takes thousands of hours to put together. I'm not talking about, I don't really mean that it takes that amount of time and effort to create a Seaboard, but it's about the finish of materials, it's about the quality of craftsmanship and the attitude towards design. By way of illustration, and I like this bit, I'm going to pass this around. This is a top dial from a Seaboard. Please treat it very carefully, it is somebody's baby. If you look at how Apple did the click wheel on their iPod, or other companies do controls like this, it'll be a capacitive touch control. There'll be 2 or 3 components, no moving parts. The thing's got a center button, and so you don't have a central shaft that you can pivot the edge dial around. So it's a little bit of a design challenge. What we did was we engineered something a little bit like a Swiss watch. I'll pass this around. Please don't drop it, please don't put it in your pocket. Here's what it looks like. Here are the number of components that go into just that top dial. And have a feel of it, it's lovely. It's like video equipment used to be 25 years ago when a video mixer cost more than people's houses. But actually, when I first came here, my attitude was that this approach to design was a bit crazy. Firstly, because it's very time consuming. Secondly, because it's quite expensive. And thirdly, because it drives people mad assembling that kind of stuff and finessing it and getting it right. And I had a lot to learn, quite clearly, because this approach has really worked for us. Where was I going with this? Where I was going with it, I'll pick up Exhibit B, which is a rather unprepossessing piece of angle iron. This is actually a Product of the Year award from the Design Museum, and we won it for Seaboard. And it's that kind of attention that you can get from doing something to an extraordinary high degree that's technically difficult. That gives you publicity that you just couldn't buy as a company our size. In fact, people just can't buy. This is only one of a number of kind of awards and gongs we've been given for either the Seaboard or for ROLI as a company. And if you look at it, it's a piece of angle iron painted blue, which is a very strange Product of the Year award, but I think the Design Museum knows that it's not the gong that's important, it's what comes with it, and so they don't put much effort into this. So maybe they're going with a kind of Apple, a music instrument manufacturer approach to just getting the thing out the door. It's good to see they're pragmatists. I'll leave that there for now. I won't pass it around. It's bloody heavy. What is a Seaboard? This brings me to my second set of things. Why is it difficult? It's a hard maths and physics problem. It's also a hard organisational problem. I'll cover that later, but the difficulty is what I want to talk about. And I've got notes here just in case I'm under-rehearsed. I'm not under-rehearsed, am I? Now this is a triumph over adversity narrative, as most engineering narratives are. One of the most compelling things that people can hear is a story about how difficult something is. Disney wouldn't exist if it weren't for triumph over adversity stories. And neither would TED Talks. Maybe we could be thankful for that. The physical world is the enemy of the designer. I mean, apart from the top dial which you've seen and getting that to work and making this beautiful aluminium chassis and the stand that goes with it and all kinds of other things, the case that goes in. There's a lot of different design elements to get right for a project like this. And these things are never right on the first issue. There's always finessing, there's always ideas that come throughout the making process. I'm going to talk about the bit that interfaces with electronics because that was basically what brought me here. That was why I was, well, semi-asked, semi-volunteered to join ROLI. So, by way of illustration, these are some of the silicon key mats that didn't make it. This was a photograph I just took in the Arches a few days ago without telling anybody. But actually, during the process of manufacture, during the process of creation, there were boxes and boxes of these made. To get this kind of silicon key mat right is something that not many people have ever tried. In fact, nobody's ever tried to do it. There's a coupling of two different properties that you need. You need a very resilient top surface that's going to resist years of playing, and we had to do accelerated wear testing on it to make sure that it would, and it does. And you find if you leave these things lying around museums and if you leave them lying around in demo places and you don't look after them, people will actually try and break them for you, because that's what a small percentage of humanity is like. So we've had people try and gouge chunks out of this. We've had people try and essentially rip the silicon key mat off the Seaboard before, and it's withstood to a large extent all of those challenges. But coupled with that kind of hard outer layer, it's like a sensitive individual, it's got a soft underside. You need that for two reasons. You need that to transmit the force to the actual sensor actuation material. You also need it because no Seaboard player, no pianist wants to get RSI. And if you have a hard surface underneath, it's going to hurt when you play it. And so we started off with this kind of solution with just two layers, and we ended up going to a much larger number, then rolling back to a smaller number. But it was a very iterative process. And there are also a number of other things that aren't really to do with the feel of the Seaboard. So, for example, when we first started casting molds, we made the keys quite tall. When you make the keys quite tall, you increase the angle of the wave on the mold, and it means that when these things are curing, the wall thickness is less because of gravity. And you can find problems such as bubbles or imperfections on the side walls of the Seaboard, so we had to do some research on that. Other problems we encountered, it tends to be the case when you're using silicon that hard materials are water-based and soft materials are oil-based. And if you combine the two, you get osmosis, and the oil goes into the top layer, and you find yourself with buckling and wrinkling. Our whole process was just extraordinarily fraught. We got it right. It was one of the last things we got right before putting this into manufacture. And actually now, as we attempt to scale up and build more of the things, we're looking at different materials and different techniques again. So that's just one of the examples of an engineering problem we had to overcome. Here's the second one. This is the Seaboard without the top case, without the silicon on, so underneath it. And this is forgive me because this is actually not a production Seaboard. This is one that we made about 18 months ago now, I think. So one of the first that we started taking out to people to play. All these elements here are force-sensitive resistors. There's 14 of them in an octave because they're linearly spaced. So essentially you need an extra one between E and F and an extra one between B and C, so hence 14 an octave rather than 12. That has a couple of implications. The most important one being, well, one of the most, I'm not going to put them in rank order, 2 implications. First one is that the spacing between these sensors is either a semitone or a quarter tone depending on where you are, which is fun. The second implication of that is that if you have exactly as many sensors as you have keys, you have a problem, most of us here are aware of the implications of sampling theory, with a sort of spatial aliasing. So it's impossible for Seaboard to disambiguate between, say, playing C and C sharp together with 2 fingers, or playing a note exactly between the 2, which is 3 decibels harder. You can't do it because you've got, the data pattern looks exactly the same. So there are ways to mitigate that using a kind of temporal approach and seeing if you can detect when things were hit and at what time. That's a bit risky as well, that doesn't work. And what we ended up doing was making a design compromise which actually served us quite well. So if you play legato on a Seaboard, it's the same as a slide would be. So we don't attempt to disambiguate, and that actually becomes quite a powerful performance feature. And we actually engineered Seaboard so even when it didn't have to do that, so when between E and F where you have 2 sensors, and B and C where you also have 2 sensors and you can disambiguate, we make it behave the same way, and it becomes part of the way that a Seaboard is performed. In fact, nowadays we could probably double the spatial resolution and do something more with this. Actually, it's become such a powerful feature that we probably wouldn't want to turn it off. So there's a sort of debate as to whether issue 1 features necessarily have to should necessarily be dropped just because you don't have to do them anymore. So what else is difficult about it? Mathematics. So 14 per octave of sensors. 1 at each end just to mitigate edge effects. That's 105 sensors in a Seaboard grand. They're scanned at something over a kilohertz, so that's about 120,000 data points a second of 16-bit analog data to process. That's probably not very impressive in video terms, but it is actually quite a lot of work to do. What was I going to say? To do it with the musical instrument priorities of having very low latency and high accuracy is also quite a tricky thing to do. Everything ends up as a bandpass filter in sensor technology. You get data in from an analog device, and you want to get rid of the noise, which is always high frequency, and you also want to subtract some of the low frequency stuff, which is usually the effect of having a mass of a key mat on top of it, and viscosity effects you get from playing the Seaboard and then taking your hands off, and it takes a little while to recover back to where it was. So you want to roll off high frequencies, want to roll off low frequencies. Everything looks like a bandpass filter. If you go into neuroscience, for similar reasons, everything ends up looking like a bandpass filter. We use them everywhere. Beyond that, there's such stuff as event tracking. So when one plays a note and wants to move it to another place, sometimes the movement of a finger is not necessarily linear. It will skid over the keyboard. So to some extent, you've got to track and provide continuity to an event, and there are some temporal aspects and some spatial aspects to doing it right. So the digital signal processing area of things was a bit of a design challenge. And actually, all of this is subordinate to the biggest design challenges we have, which are simply by view of trying to create something that nobody has created before. Specifications, such as MIDI and USB, become cultural conventions which become straitjackets, and nobody really seems to notice it until you try and do something else. So if you look at the way any keyboard controller is designed, it will have a keyboard of keys, and it will have a pitch wheel on it, and it will have a modulation wheel on it. And the only reason they still look like that, and they have done since 1982, is because that's what the MIDI spec does, and that's what the MIDI spec knows how to use. And if you do anything else, you're writing yourself a check for a whole load of trouble. That part of the industry moves quite slowly. There is now a specification in development that's attempting to supplant MIDI, build on it, do something else in order to get musical data from one instrument to another. It's been in draft for at least 6 years. I don't know when it's going to surface, and if it does surface, I don't know if we're going to find it particularly useful. So, in the light of that, we had to do two things. The first thing we did was use the system exclusive layer of MIDI, which is a kind of get-out-of-free card where you can use the musical instrument interface to send a whole load of proprietary data, as long as you pay the MIDI Manufacturers Association a few $100s a year for the privilege of having a few numbers at the beginning of it. So we have a kind of proprietary protocol that we built on top of that that allows Seaboard to do a few other things. And the other thing we did was attempt to make do with what we had. So the MIDI 1.0 spec we have had to modify. Now, what doesn't MIDI do? What MIDI doesn't do, most importantly for us, is allow you to play one note and another note and bend them independently. You just can't do it on MIDI. But MIDI does actually provide 16 channels of data. That was originally conceived to allow you to have 16 instruments. So if you wanted to have an orchestral synth at one end and a computer at the other sending it data, you could do that and have 16 different kinds of sounds coming out. For some reason, the drum trackers always channel 10, and I think that's because they didn't want to insult drummers by making them count beyond 10. Present company accepted. No problem. Adrian can count to much higher numbers, I've seen it. So what we did was we used all 16 channels. Pitch bend is applied on a channel by channel basis. Every time you play a note, it's assigned a different channel. And that's the only way to do it. Doctor Who. Anyway, every note is assigned a different channel, which is lovely until you come to other problems in the Seaboard and you kick that can further down the road. So if you want to assign, say, channel number 1, every time you play it, you want it to be assigned channel number 1. Synthesizers that don't understand you're communicating them with them on many different channels will otherwise pile up lots and lots and lots of different notes. You don't want an instrument to behave like that. So every time you press C, it's assigned channel 1. Which is great, or, well, channel nominal number. Until you get to the stage where you're playing a C, I said, this is why Heen does the demos, pitch bend it up to another note. It's still C, but it's pitch bent. Then you play C again. You don't want that to be assigned the same channel number, because if that happens, then the G will be killed, because the synthesizer will think you're messing with it. And so there are all kinds of subtleties you have to build in to make the bloody thing compatible with MIDI. And we did a fairly good job on that. There are certain things that still show it up, and it's a shortcoming of MIDI, and we have to live with it. So if you put the sustain pedal down, you suddenly ruin everything, because you can play a whole load of notes. And if you're very unlucky, one of the notes you play at the top matches the channel number of one of the notes you play at the bottom. You've got the sustain pedal down, playing far more than 16 notes, and everything will start bending together, because that's what happens. USB. USB is an interesting one. It's a marvelous specification. We love it. But there are a few things that make it quite frustrating for a musical instrument. What's particularly bitten us is the fact that there are two widely established MIDI speeds as a kind of USB 1 full speed thing and USB 2 high speed. You're probably quite familiar with this because you use computers. USB 1 is not very good for file transfer or anything that requires a high bandwidth. But what it is good for is for long cable runs and crappy cables. And if you've got a 10-meter cable, it's exactly the kind of situation you'd experience on stage. If you have a USB cable plugged in that's transmitting data to your computer, which is making a noise or triggering samples or doing whatever it is you want a Seaboard to do, it's generally probably going to be quite a long cable, probably an environment with an awful lot of radio frequency nastiness going around. What you don't want is a protocol that's going at 480 megabits per second over a twisted pair, or however fast USB 2 is. Data integrity isn't great in an environment like that, and USB 2 tends to fall over, and there's nothing you can do once you've lost it. The computer will try and retransmit a packet in error 3 times, and it'll just say, "Sod you," and it'll fall off the bus, and your whole instrument goes down until you power cycle it. So we have this problem where we need to do two things. We need USB 1 for musical instruments on stage in that kind of environment, but we also want to be able to talk to an onboard synthesizer and send it samples and send it upgrades occasionally and send it new features, and that requires a lot of data, so we want USB 2 as well. We can't have our cake and eat it. Can't solve that one yet. If you think of a way, talk to me afterwards. The other one is synthesis. And it transpires that if you want to design an electronic musical instrument that does something different, you better design a synthesizer that's compatible with it. The thing about a Seaboard is it sends out a lot of data. There are a few things, as you've heard, that can cope with it, although to be able to cope with it well relies on kind of building relationships with other companies that make synthesizers, which is all very well and good, and there have been some companies that have been absolutely wonderful for us. We've lent them Seaboards, they've made their stuff, they've tweaked their stuff to make it work well, and it's great. But the trouble with relying on other companies is it's not necessarily a business priority for them to deal with a little company like us. So if you want to start to develop your own musical technology, you better kind of go it alone. Designing a synthesizer, if any of you were at the Circle Audio talk February last year, it takes about 3 person-years to do. As a general rule of thumb, even for a fairly kind of conventional and non-groundbreaking synthesizer. And the work we're doing is a little more groundbreaking than usual. Not necessarily in terms of voice management and in terms of making new kinds of sounds, but in terms of being able to handle control data, handle it robustly, and deal with multi-channel audio data and thousands of events per second quite nicely. Because Seaboard does have the capability to send out thousands of events a second. And so we've had to kind of go it alone, and we're now rolling our own synthesizer technology. And it's coming along very nicely, but it's just another thing that you have to sort of look out for and develop and build a capability for if you're a company like us that's beginning to start out. Building a thing is also difficult. I'm going to go into this because it's quite interesting. If you want to see what a company really values, see what it spends money on. This is a picture that was taken about 9 months ago. It's on ROLI's website, and it's a picture of our other site. In 1939, this was underneath Haggerston Station, and then in 1940, the Luftwaffe decided to redecorate. But it still exists about 50 yards from where Haggerston Station is now. And it's a fairly sizable railway arch. We have 2 of these, and one of these is a factory. What you can see there is the beginnings of Seaboard being made as a sort of short-run prototype, so they're putting a few together. And the people in the front are Minsu, who's a designer, and Hegan, who's been fairly instrumental in getting the chassis work made, the aluminium work made. And in the background is Hao, who's a PhD-level pianist. There aren't many of those. She's doing a PhD at the Royal College of Music, I think. And one of her kind of side jobs is to perform with the Seaboard, and she also works in quality control to make sure that everything feels right. We're trying to automate the everything feels right thing, but it still kind of requires a brain at the end and somebody who knows how to play an instrument. So this was the early stages of manufacturing. If you look at what Kadak did, a previous employer of mine, they used to make live sound consoles, and they spent, I think, upwards of £250,000 on building themselves a test chamber for radio frequency interference. That was important to them. The reason that was important to them is they were one of the very first console manufacturers in the business that realised that they weren't building a block, they were building an instrumental part of an entire system. And this entire system was subject to long cable runs and radio frequency nonsense, and if you left a mobile phone lying about in the wrong place and it buzzed, people would blame the console. And so they had to start building a practice and an art years before other people started taking it seriously about keeping radio frequency interference out. Spent a huge amount of money on doing so because it was instrumental to their business. Well, why is building a factory instrumental to us? And this is a cultural thing. What you don't see in this arch, by the way, is the metalwork and woodwork shop, which is in the other arch, and the enormous 3-axis CNC machine we have, which we use for prototyping and for building molds for the Seaboard and for all kinds of other things. Why do we do all this? Well, there's a lot of reasons. It's about nurturing different disciplines. So in making a Seaboard and making it successfully, we've had to bring together material science and industrial designers and mechanical designers and people who are experts in metalwork and woodwork for the prototyping and electronic design. And in bringing these people together, you get sort of sparks of inspiration and accidental encounters, and having to focus together to actually make something rather than just build a blueprint enables you to have a much better insight into what it is you're building to improve, and also to improve the people who are part of that process by teaching them about areas that are otherwise outside their purview. And so actually bringing people together to build prototypes and to go through that sort of rather onerous factory process together creates a better product. The other reason that it's important is for innovation, really, because innovation is not just about making new products in a different way, it's also about innovating in the processes. A contract manufacturer in the Far East won't tell you if they think there's a better way of making a piece of equipment that requires you to change your design. The only way you're going to find out is to start building the thing yourself and using your own insights and your own training and your own expertise. And so building these craft skills is integral to what we do, and it's how we innovate and it's how we continue to produce the things that we do. Continuing to innovate is the lifeblood of any company that isn't enormous. If you're Samsung, your new phone can be a bit faster than your old phone, and no one's going to complain about it. Conversely, if you're a company like ours, and we don't employ hundreds of thousands of people over many, many countries and many different sites, if you're a company like us and you decide to enter a price war with a much larger company and they see you as a bit of a threat, they can put you out of business by taking a small loss on the few of the products they're selling and undercutting you so nobody goes and buys your stuff. It's a very dangerous game to play. So if you can't compete on price, and you can't compete on volume, and you can't really compete on marketing effort, even though we've done a pretty good job ourselves, you can compete on being innovative and mobile and responding quickly to the world and doing things like this. We actually found ourselves, quite fortunately with the Seaboard, in a very good place. What we've done is we've developed a musical instrument, certainly. We've entered the music instrument industry, and we can continue to build that and do things with the Seaboard and try and develop those ideas and see if anything comes of that. We've also built a sort of sensor technology. And the stuff I've been showing you is necessarily about 18 months old, because I can't show you what we're working on now, unfortunately. But in continuing to build that sensor technology, there's other areas we can explore. And it's interesting, if you look at, for example, personal mobile devices, and you look at the kind of trajectory that they've taken, there's a couple of bottlenecks now, and processing power isn't one of them. People want extra battery life, of course, and they want better screens, but actually what we're looking at now, where the bottlenecks are in two areas, basically speed of connection to the rest of the universe, which we can't help them with, but also the ability to interact in a meaningful way with the equipment. The bottleneck suddenly becomes a sort of human-machine interface when you're stabbing numbly with your forehead at a tiny keypad. There must be better ways, and our technology enables people to feel their way around. What we've got is it's not just a multi-touch surface, it's a multi-touch surface with pressure, with resilience. The haptic feedback you get from it is far superior to anything you get when you're stabbing on a piece of glass. And so we've, well, not by accident, but by kind of design and by realising this was an interesting angle to explore, we've built ourselves a fairly compelling sensor technology. But continuing to innovate is quite difficult by very nature. If you're doing research, you kind of don't know what you're doing until you've done it. And that's why I'm head of research. It's interesting. Research takes two directions. You can think of a product and find a way of getting there, or you can take what you've got already and make it better. Both ways usually end up in product design, and the whole idea of research is to mitigate the technical risks to the extent where you can actually build something, but also to preserve the culture of being able to embrace and work on that risk. One of the things that ROLI does in order to encourage imaginative people to keep creating is to generate slack time for people. So on Friday afternoons we devote, well, essentially 10% of our working lives to projects that people just think of. And they pitch them a bit like business ideas, but they can be anything that adds value to what we're doing. There are some fairly crazy ideas and some fairly sensible ones, but people go off and they work on things that aren't official orthodox projects and see where they go for 6 to 12 weeks and then keep reviewing them and decide whether or not to pursue them. And actually giving engineers slack time is an extraordinarily important thing to do. And I realised this in my previous employment at Focusrite. For some reason or another they were changing the way that their product system worked, and I found myself without anything to do for 3 months. And giving an engineer nothing to do for 3 months means that they generally sort of get itchy fingers and start pursuing other things. I started playing with some stuff I did in a PhD thesis about binaural audio synthesis, and was researching that and wrote a few little tools to put things in certain places in a room and then to sample loudspeakers, and eventually created Focusrite VRM, which was their only patent. And that was because they gave me nothing to do for 3 months. Actually, if you're going to employ creative people and tell them exactly what to work on, it's kind of a waste of talent. And we need to get better at this as an industry. But it's also the nature of running a real business that if you've got people you're underusing, you want to be able to use them. So there's always going to be a tension between how occupied people are. It's a difficult job for me anyway. I'm glad it's my responsibility because it keeps me away from mischief. Research joke. The weakest conclusion ever. You can use it at the end of any paper. Initial results are promising. I'm not very good at calling anything a success. ROLI has done extraordinarily well so far, but I'm still holding my breath until... I don't know. How do you know when anything is a success? They say political careers always end in failure. Give a company enough time, give it a millennium or so, and eventually something is going to end. But actually what we've built so far in the last kind of 2 or 3 years where ROLI has been seriously working on this is a culture of innovation. We've developed and shipped a product, we have a full order book, things are going very nicely. And we've turned the kind of disruptive technology model on its head by actually paying attention to the quality of the product we're creating. So I would just, if you take anything away from this talk, I'd like it to be that there's probably more than one way to do this. Look at what the rest of the industry is doing, but you can completely ignore them. That's essentially my conclusion. There's some time now for some on-mic questions. I'd like to thank John again for providing the speakers. And thank everybody for coming, and thank ROLI for the use of their venue. Anybody have any questions?
I ask you to use the microphone if you do.
Somebody over there? Let me just out. Sorry?
That's all good.
You can talk, you know.
No, it's fine. It's fine.
Right. Does anybody want to talk? Don't leave it all to me, please. Well, what we can do is we can...
I should like to ask, is the sounds that we heard tonight, is that your synthesizer, or is that just using the...
No, it's not. It's our sound design. So we have somebody who's designing sound especially for Seaboard. But actually that at the moment is something that's made by a company called Expansion, who are actually based in London, we've been working with. And actually when Seaboard ships at the moment, because the synthesizer isn't ready, it ships with a version of their player.
And where is the synthesizer?
It's hosted in a Mac at the moment. We've got an enormously powerful processor inside Seaboard that's just waiting to run a sound engine. And that's going to be ready real soon.
Ben, you spoke about issues with USB. So what USB does this run off then?
This is currently USB 2, but we're working on that because of the data integrity issues that some customers have been having. So for performance mode it'll be 1.1. For other things, we'll see if that's acceptable, and if it's not, we're going to have to go for a sort of dual mode system.
Is it compatible with any sort of VST instrument and kind of connect it up really easy and assign different parameters to it?
There are a few, we actually have a piece of software called Polythrough, and the point of Polythrough is that it is a way of taking an instrument that isn't necessarily multi-MIDI channel compatible and building several instantiations of it invisibly. So we provide people with that tool, and then you can use it for a VST instrument, but processing power can go up when you do that. Processor use, rather. Anything else? I don't know what I'm going to play. See, even I can keep it in tune. Please, what we can do now, I think it'll be best if we have off-mic questions and we kind of mill around and schmooze as we do at AES Do's, and help yourself to coffee and play this, but not at the same time. Thank you very much.